Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 4th May 2023. The problem statement for today is max coins. Let's now open this problem to solve it. Let's go through and understand the given problem statement. The problem statement says you are given a 2D integer array ranges whose length is n where ranges of I that consist of three elements, that is start point, ending point and the number of coins. This means all integers from start of I to end of I inclusive start of I and end of I are present, and we get coins of I, amount of coin, when we select ith range. You can select at most two intervals so as to collect the maximum coins, but if you select two ranges, then two ranges should not intersect and overlap. Okay, then the two ranges should not intersect or overlap, then can touch each other. Okay, so you can select maximum two ranges and they should not intersect each other, but they can touch themselves. So they by this statement it means that the ending point of one range that can touch the starting point of the next range, but it cannot intersect. Okay, so here the problem statement is asking us, it is saying us that there are a given number of ranges and each range has a start point, end point and the number of coins associated with it. The goal is to find the maximum number of coins that can be collected by choosing a set of non-overlapping ranges. Okay, let's go through the given examples to understand it in a better way. So the first example says that there the n is equal to 3. So the length of this ranges array, that is 3, and this array contains these three sets here. So each set consists of a starting point, end point and the number of coins associated with it. So the first set consists of starting point as 1, ending point as 3, coins is number of coins is 4. Similarly for second and third set, where starting point is 2, ending point is 3 and number of coins is 5. Here the starting point is 3, ending point is 4 and number of coins is 5. So here the explanation is 7. Here the output is 7. In explanation it is given that we can see that we can take second and the third ranges as they are not intersecting, only touching. We can get the maximum coins by taking these ranges, that is 5 plus 2, that is equal to 7. So if we look at this one, first and the second one, then the ending point of the first range is beyond the starting point of the second range. That means these two ranges are overlapping. But if you see the second and third one, so ending point of the second set is 3 and starting point of the third one is 3. So it is just touching, it is not intersecting, it is not overlapping. But in case of the previous first and second set, the starting point of the second was before the ending point of the first set. So this was overlapping. So that's why this 4 is not considered. 5 and 2 has been added, which gives the output as 7. Let's go through the second example. Here it says that length of this array is 5 and 5 sets are there in this 2D array. Here the output is 14. We can see that we can take second and fourth ranges as they are not intersecting, and we get the maximum coins, that is 5 plus 9 is equal to 14, by taking these ranges. So here it is said that it has taken ranges 5 and 9. Okay, so we are getting total number of 14. If you try to take any other range which can give the more number of coins, then we can see it is overlapping. Okay, so here you can see if you take second and fifth one, then again the same problem. Here the ending point is 3, but here starting point is 2, so overlapping. If you try to take this one 9, the fourth and fifth one, so here it is saying even the starting point of this one, starting point is 5, ending point is 8, but here the starting point is 2 and ending point is 8. So the fourth one lies completely within that. So again this is not correct. It should not overlap or intersect. It is should the only concession given is that it can just touch each other. Okay, so that's why it has been considered second and the fourth one, because here it is 2 and 3. Starting is 2, ending is 3. Here starting is 5, ending is 8. So these two sets are completely independent, completely independent. So we can add these two, so we get the value output as 14. Okay, so I hope the given problem statement and the examples both are clear to you. So for solving this problem, what we will do, the approach which we will use is to sort the given ranges by their endpoint in ascending order. Then we iterate through each range and calculate the maximum number of coins that can be collected by including that range in the set of chosen ranges. To do this, we call a function, some name like getMaximumCoinsInRange, that returns the maximum number of coins that can be collected from all the ranges whose endpoint is less than or equal to the endpoint of the current range. Okay, so we are having one current range, and we are giving, so this function will give the maximum number of coins that can be collected up to this range, so that whatever is the value in this range, we can add directly to that. Okay, and what that function does, that means get maximum coin in range, it uses a binary search to find the range whose endpoint is closest to the given endpoint. It returns the number of coins associated with that range if found, otherwise it returns 0. Okay, so whatever the range we are defining, we will be passing the starting point of the current range to that list of to that method with the range list. So we will find that we will find the range whose endpoint is closest to the starting point of the current range, and whatever is the value associated with that we will it will return, otherwise it will return 0. Okay, so once this is done, then what we will do, we'll keep track of the maximum number of coins collected so far and returns it at the end. Okay, so let's understand this example, this approach with one example. So here I've taken the first example for understanding this one. So first, what we are doing, first we are sorting these ranges by their endpoint in ascending order. So here it was already in the sorted order only in the given input. So even after sorting, the range is still the same. Okay, so initially the range list will be blank. So the maximum value in that range is 0 when we are looking for the first one. So what is the number of coins associated with it? It is 4. So the max coin is 4 as of now. And in the range list, since we have visited this one, then we are adding this to the range list. So for adding this range list, we have a condition there, that if the endpoint value from the previous range, if it is less than the current one, then we add this range to the range list. Since it was empty, so we can say that it was 0 in the previous case, and we are getting some value in this one. So this range is added into the range list. Okay. After that, once this is done, then we have this one in the range list. Now we are going with this set. So here we can see, here the ending point was 3 and here the starting point is 2. Okay, so it is overlapping. So what it happens that we get the maximum value in this range as 0, because this condition is not valid according to the problem statement. So that's why we are neglecting that, we are completely differing that. So this one is not considered. Then we check whether this is having the maximum or the previous one was the maximum. So what we do, so whatever it is returned from this method, that means the maximum value in the range, to that we try adding the value of the current one. So since it returns 0, then we added 5. Then we compared whether 4 was maximum or this 5 is maximum. So whatever is the 5, so this one 5 is maximum, so the max one we have got 5. and the value in the last range, that was 4, but this time we are getting 5. So now, since this is the value in the current range is greater than the value in the last range, we are adding this range. That means, we are adding this value, this map and this range into this range list. That means 3 and 5. 3 is the endpoint of that current set, and 5 is the value associated with that. So now, after this again, it will take this value. It will take the endpoint of this one 3, and it will take the starting point of this one, and it will pass this to the method from where we are doing the binary search to get the maximum value. So from that we can see that since it is not overlapping, it is just touching each other. So it returns the maximum value associated with that set that we can get. So it is 5. So now to this resultant we add 2 to it. So now maximum coin will become 7. So now we can see that value in the last range it was 5, but this time we are getting value as 2, so we are not adding into the list. Anyway, it doesn't matter because we have to only take 2 intervals. Okay, so we are not adding that to range, so that if in case some other set also comes there, so we will just compare whether this one is the maximum or the new set with the value or the number of coins associated with that. If it is greater, then the value or the maximum coin that we will get, that will be greater in this case than the previous one. So here now we have got the maximum coin is 7, and we are not adding this the range, this one, that is 4 and 2 into the set. The reason that if we get some extra set there, so for that I have taken another example. Just I have added one extra set here. So if I am taking extra set here, then in that case till now the maximum coin was 7. Now if we add that set into this list, first of all, the condition is not fulfilling. That means the value in the current set, if it is greater than the previous one, then only we add. Since it is less than the previous one, we do not add, but we have considered that value, but we have added that value to the max coin, so that when we get any new set here, so that it can compare whether to take this set or this set. It will be depend on the value. It will depend on the fact that which set gives the maximum value. So it is 5 plus 2, it was giving 7, but it is here 5 plus 6, it is giving 11. So the max coin here it is 11. Okay, so that's why this set is not added here, but we have considered the number of coins associated with that. But if it is having the value greater than the value in the last range, then we will add that one. Okay, since we have to consider only 2 intervals, that's why we are doing this way. Okay, so this was the coding part of it. This was the approach. This approach we will be following in this solution. So now let's move to this editor. First I will solve for Java. I have prepared the solution. Let me just copy it here. So whatever the approach I have explained with that example, same thing we have done here in the coding as well. So what we do, first we are sorting the ranges by their endpoints in the ascending order. In case of a tie, then we are sorting them by their starting point in ascending order. This helps in determining which range can be traversed without going out of the bounds. Okay. After that, we create a list to hold the ranges and their corresponding coin values. So for that, we are creating a list of map here. Then we initialize a variable called max coins, and we initialize the value 0 to 8. Then we iterate through each ranges and calculate the maximum number of coins that can be collected by traversing the ranges ending at or before the current range starting point. Okay, so what we will try to calculate the maximum number of coins that can be collected by traversing the ranges ending at or before the current range starting point. So whatever the value we have got till the last range, we get that value, and to that we add the value whatever we are getting in the current range, that is range of 2, because the in this set, the in this array, the index position at index position 2 only we get the value, the number of coins associated with that set. So to that previous set value we add this range. Okay, and how we are getting the maximum coins in range? For that, we are using binary search in this one. Yeah, here we are using binary search to find the index of the last range whose ending point is less than or equal to the current range starting point. If such a range is found, then the maximum number of coin is added to the maximum number of coins found so far. Okay, so here we are passing this range list and this end is actually the starting point of the current range, so that this can be used to check the condition that the range of the previous set that has to be less than or equal to the current range. It cannot go beyond this. Okay, so from this one we are performing binary search to find the last range in the range list with the end of I value less than or equal to the end. Okay, so whatever the value we are getting, it is returning the coin value associated in that range. So that we are getting here, and to that we are adding the current range value, current range number of coins. Okay. So, and after that, if the current range has more coins than the previous range, here we are checking if the current range is having more number of coins than the previous range, then this set is added to the list of the ranges that can be traversed without going out of the bound. So if the value we have got in the previous step that is less than the current range, then we add the current range to the list, and this will continue for all the ranges, and at last we return the maximum number of coins that can be collected. Okay, so this was the coding part of it. Let me try compiling this code. So here we can see we have got correct output for this given input. Let's try submitting the solution. So here you can see it has covered all the test cases. So this problem has been solved successfully. So this was the Java solution of it. So if we talk about the time complexity, the time complexity of this function is big O of n log n, where n is the number of ranges. This is because the function first sorts the range based on their endpoints, which takes big O of n log n time. Then it iterates through the sorted range and performs constant time operations for each range. The time complexity of getMaximumCoinsInRange function is big O of log n, where n is the size of the range list. This is because the function performs a binary search on the range list, which takes big O of log n time. So overall time complexity of the algorithm is dominated by the sorting step and is big O of n log n. Okay, so this was a Java solution. I have even prepared C++ solution. Let me move to C++ editor. Let me copy that code as well. Here also we are doing the same thing, same logic, everything, only the difference in the syntax in C++ and Java that is there. So here also we are first sorting the given ranges based on their endpoint. If it is not, then based on the starting point if the endpoint ties. Then after that we create a range list, then we add it over the entire ranges, we get the maximum coins in range, and whatever the value we get, to that we add the coin associated with the current range to it. So whatever the value we get, to that we add the number of coins we are getting in the current range. Then we check which one is the maximum coin this we are getting, so or the whatever we have got in the previous step. which one is the maximum, that is again updated in the max coins value. And here we see, if you see that among the range list, whatever the value we are getting in the previous step, if that is lesser than the current one, then we add this current range into the range list. So this will this operation will be done for all the sets in this range list, in the given ranges in the input. Once this is done, then whatever the value stored in this max coin, that will be returned. And here inside this getMaximumCoinsInRange, here also we are performing the same binary search to get the maximum coin associated with the associated in the range list, that is following one condition. That means the ending point of all those range lists should be less than or equal to the starting point of the current range, which we have passed in this variable end. So this is actually the starting point of the current range, and from this range list we will try finding that which range satisfies that condition and what is the value associated with that range. So whatever is the value associated in that range, that we are returning it back. So that only value we will get here, and to that we add the current value, that means current coin number, and max coin is getting updated. So the logic is completely same, just the difference in syntax. So let me try compiling this code. So here we can see even with C++ solution we have got correct output. Let me try submitting the solution. So even with C++ solution we have got the correct solution. It has passed, all cases are passed in, even in this one. So this has been solved successfully using both languages, C++ and Java. So I'll provide the link for this question and the link for the solution code in Java and C++ in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.